Hello student. Yes, so in this video we are looking at the solving of simultaneous equations by matrix method. The truth is, it is a very simple algorithm that you need to follow slowly and you understand. So we have our first example that use matrix method to solve the simultaneous equations. We have there y is equal to x plus 3 and then 2y plus x is equal to 11. So as part of our solution, if we look at these equations, they are not arranged properly. So the easiest way that we are used to is arranging x plus y form. So I will put the unknowns on one side and the knowns on the other side. So I get this guy, bring it to this side, so it's going to be negative. I have there negative 2x plus y is equal to a positive 3, and then I can have here and x plus 2y is equal to 11. In other words, if you begin here with x and y, if you begin here with x, make sure it is x is beginning. If you begin here with y, make sure it is y that is beginning, such that you don't get alternate values, because if you alternate them, then it means you're going to get the value of x for y and then the y for x, such that after doing this, the rearrangement, we've rearranged them, so we can arrange them in matrix form now. So we can say matrix, the matrix form. So if we had put those guys in matrix form, we get the matrix of coefficients, which are these ones, the constants in front of these figures. In this case, we have negative 2 and then 1 in front of x. We have 1 and 2 in front of y. Then we create the matrix for the unknowns x, y. And then this will equal to the matrix for our constant 3, 11, such that for the knowns 3, 11. After which now, if we let denote a matrix, which is the coefficients matrix, negative 2, 1, 1, 2, then we get its adjoint. When we get the adjoint of a, we multiply both sides of the equation by the adjoint of the matrix. We've seen how we get adjoint. So the elements in the major diagonal, they change their positions, and those in the minor, they change signs. So if we are to have a shift in positions here, we're going to have a 2 shifting, a negative 2 going the other side. These guys, they change their signs, the ones in the minor diagonal. So we multiply both sides of the equation by that guy. So we have a 2 negative 1, a 2 negative 1, negative 1, negative 2. Then we are multiplying it by negative 2, 1, 1, 2. Then we have here an xy. This will equal to, open brackets, still 2 negative 1 negative 1 negative 2, the adjoint, multiplied by 3 with 11. So that we multiply, you show the matrix multiplication, don't multiply by head and plug in the values here direct. So if we go row by column, I have here 2 times negative 2, I have here 2 multiplied by negative 2, 2 multiplied by negative 2, and then this is row by column. Then I have here negative 1 times this case, so this is plus negative 1 multiplied by a 1. Then I still go row by column. I have your negative this times that guy, so I have negative 1 multiplied by negative 2, then plus negative 2 times 1. Then I again go row by column, produce the next digit here. I'm going to have a 2 multiplied by, this is row by column. I have a 2 multiplied by 1, then plus a negative 1 times 2. Then again go row by column. I'm going to have a negative 1 multiplied by 1, then plus a negative 2 times 2. So remember to put the matrices, and then this I'm multiplying it with x, y, so that this will equal to, open brackets, still this side we are multiplying row by column. So this side row by column, I'm going to have here this guy times this is going to be 6. This is a row by column, 2 times this guy is here 6. I see here a 6, and then I have negative 1. Okay, let me multiply them normally. So first, I didn't want to do that, but allow me to do it. So this is going to be 2 times 3, 2 times 3. Then I have here plus a negative 1 times 11. Then again, row by column, I have here negative 1 times 3. Then plus negative 2 times 11. Then make sure that you put the matrices. Yeah, put the matrices. So we have negative 2 times 2. This is going to be negative 4 plus negative 1. Then they have here positive 2 plus a negative 2. Then have here a 2 minus 2. Then I have here a negative 1 minus 4. Negative 1 minus 4 into xy into x with y. So this will equal to, I have here a 6. I see a 6 minus 11. Then I have here a negative, I think a negative 3. Yeah, a negative 3. Then this guy is negative 2 times this guy. This is minus 22. Minus 22. So that if I add, I get here a negative 5, a 0. A negative 5, a 0. A 0 with negative 5. Then into xy. This will equal to, I see here a negative 5 and a negative 25. So if you multiply again row by column, I say negative 5x, a negative 5x with a negative 5y. That will equal to a negative 5 with a negative 25. Such that now what we do here is we equate corresponding components. Once we equate corresponding components, so if I say equating corresponding components or components in similar positions, I'm going to have negative 5x will equal to a negative 5. If I divide through by negative 5, divide through by negative 5, my x will equal to a positive 1. And then I have a negative 5y will equal to negative 25. I divide through here by negative 5 by negative 5. My y is equal to a positive 5. But this is what I'm saying. So many guys love crossing. If you say you are going to cross, you say by 5 1, 5 into 5 1, by 5 1 into 5 1, by 5 1 into 5 1, by 5 1 into 25. This is a 5, such that y is equal to 5. Don't just cross and go away. Otherwise, hope you guys have tried to follow. Anywhere you are lost, you are free to consult or inbox privately. Otherwise, remember to hit the notification button so that every time we upload new videos, you keep notified and you keep following. Otherwise, wish you the very best from all our team.